combined coplanar waveguide and microstrip. And the authors are from National Zhonghua University. And the presenter is Wei-Kun Xu. Mr. Wei-Kun Xu.
Good afternoon, ladies and gentlemen. It is my pleasure to present a paper here. And there we come to our topic. The topic of our presentation is UMTS diplacer design using combined coplanar waveguide and microstrip. And I am Wei-Kun Xu. I come from National Zhonghua University of Education, Taiwan. Before the main presentation, I will give you an outline of this paper. First, I will introduce how diplacer works in communication system. And second, I will introduce some interesting diplacer equipment will be presented. And the third, I will show some learned elements accomplished by CPW and microstrip structure. Next, I will introduce the filter design for diplacer. And finally, a proposed diplacer specified for UMTS frequencies and requirement is presented. The more one is conclusion and less one is reference. The configuration of diplacer is shown in the figure, which is the 3-port multiple frequency operation device. Here connect to TX port and here connect to RX port. And the third port here is connected to the antenna. It can transmit and receive at the same time by frequency division duplex method. Transmit and receive frequency must be close together in frequency spectrum for efficient bandwidth usage. Thus, we can use narrow band and high gain antenna to optimize antenna performance. In a universal mobile communication system spectrum, we use 1920 MHz to 1980 MHz for transmit band and 2110 MHz to 2170 MHz for receive band. The total frequency is 12% bandwidth and it is very narrow bandwidth usage for diplacer. We will use CPW and microstrip structure to implement the circuit design because it is planar structure and easy to fabricate it. And the combined CPW and microstrip has double layer configuration. Use 2-layer characteristic. We can make a smooth size circuit because we place components on both sides. Now I'll show some interesting diplacers for UMTS applications. In this picture, present the structure of our diplacer. It was combined of 2 CPW and microstrip filters and parallel connect together by microstrip line. The first of the proposed structure is a UMTS diplacer combined by 2-loop resonators filter. In 2002, 210% and CUPAS have proposed this structure. The diplacer is used 2 resonators and coupled together. And this is its circuit structure, and this is its frequency response. Here are insertion losses and return losses, and here are its isolation. 2003, coupled has also present a compact ones, and it has addition zeros, sharpening band edge roll-off. Here show circuit structure, and here show the frequency responses. In figure, we can see a filter has addition transmission zeros. In 2007, He, Xu, and Chen have proposed a microstrip dual-mode ring diplacer for UMTS application. With each ring, its input and output ports separated from quarter wavelengths, which creates the degenerate resonance. The structure can precisely tune the position of zeros for increasing the isolation between the RX and TX port. Here shows the circuit structure, and here shows the frequency response. I propose structure for the comparison. All insertion losses are about 2 dB. The isolation of all diplacer is over 35 dB. But in the overall circuit size, I have a structure for 328.5 mm squared. This shows that we still have the structure proposed by the shrinking size of the rule of circuit. Now I will introduce some lumped circuit elements implemented by CPW and microstrip. In transmission line theory, a large characteristic impedance lines can be considered as a series inductor, and a small characteristic impedance line can be considered as a shunt capacitor. This is microstrip structure. The strip line is on the top side and the ground is on the bottom side. In microstrip structure, the white line can be considered as a shunt capacitor, and label line can be considered as a series inductors. Here is can be considered as a capacitor, and here can be considered as inductors. This is CPW structure. In CPW structure, there are large ranges in impedance value, because we can decide the distance between the strip line and the ground to change the impedance. So we can design an accurate lumped component.